Yeah.
50, yeah, I have 15 minutes to eat.
So you just multitask. Okay. Our other module today is impact prediction. I'm going to cut some of this content short. It's actually a pretty straightforward topic, but I'll cut short the activities I had lined up just in the interests of getting some time to talk about group work at the end. But what we want to do is to start thinking about, well, how do we actually explain impacts in an EIA? And that includes predicting them. So and the big reflection question is, what exactly should be predicted in an EIA? So I've mentioned prediction a lot already. In that definition of impact assessment used by the International Association for Impact Assessment, it's clear that they frame EIA as a predictive exercise, thinking about future consequences. Future consequences means forecasting or predicting. It's implicit in the definition there. And the other point I'd make on this slide, because I'm showing you graphics so you've seen many times before, but a key thing to bear in mind is that it's the proponent who's generally considered to be responsible for predicting impacts. And if you know your international environmental law, that makes perfect sense. We have a principle in international environmental law called the polluter pays philosophy. The person who causes a trouble, pollution, should pay to clean it up. And that philosophy underpins EIA. It is the proponent of development who wants to cause environmental impact and make lots of money from their development. I mean, no mining company ever proposes to go bankrupt. They always propose to make lots of profit for their shareholders. So the proponent's going to make money from their business enterprise. That's their plan. But they're going to cause adverse impact. Therefore, the responsibility should be on them, not only to explain what the likely impacts are going to be, but also, of course, to pick up the cost for restoring and protecting the environment. So the polluter pays principle is there. What is an impact prediction? Well, it's a statement that predicts a change or no change to any part of the environment as a result of proposal implementation. I previously gave you the definition of impact and effect in Western Australia from the practice manual, practice guide. So it's the same sort of wording. The term environmental impact refers to the physical change resulting from a proposal. The environmental effect refers to the consequence of that change for the environment. So the the flow-on effects that arise. So if we didn't have this project, this proposal, if we didn't have this development project, we would not have this change occurring. But you can also, of course, predict that something will not occur to put people's minds at rest. Here's a diagram that explains the same thing. So you've got this environmental baseline, the green line, and there's a moment when you construct the project. And in this instance, it looks like the construction, I don't know what the impact is, but it looks like the construction phase has a particularly big impact. Maybe it's dust or something. And then once the construction phase is finished and whatever this development activity is that's ongoing, you've still changed the environment. The actual level of impact is a bit lower than it was during construction, but it's still there. And in this case, it seems to be growing over time. So there's something going on there. I don't know what this development is, don't know what the impact is. But the point is that we wouldn't have that project impact if the project had never happened. That's what's going on there. Now, there's an important note here. An impact requires a receptor. When you have an impact, someone or something must be being impacted. And emissions like dust and noise are not impacts. Noise is noise, dust is dust. You only have an impact when someone or something is being adversely affected. So if you're an asthmatic and there's a bit of dust, you might be in hospital now, and that's bad news. Someone who's a non-asthmatic might be totally fine with that dust. And the same with plants and animals. This species might be very susceptible to a change in acidity in the soil. This one may not be. So you don't just say it's acidity, acidity's changed. you have to actually have someone or something being impacted. So just pay attention to that. Don't be sloppy. Sometimes you'll see sloppiness in international journal papers on that point. So just be attentive to it. So I said a prediction is of a change or no change. So here's some simple examples. These ones come from my PhD research many years ago. The proposed sodium cyanide plant will not affect the amenity of the Kwinana Beach area. You've got a beach, you've got a new industrial complex, a short distance from the beach. The concern was about the aesthetics, the visual aesthetics and noise and so on, the amenity of the beach. And they're saying, well, it's not actually going to change that. It's not going to affect us. Whereas the second one's got a couple of changes indicated. It's a construction of a dam, and it says, well, the dam's going to reduce the downstream river flows. That's affecting the hydrology of the riverine pool system downstream from the dam. And because of that change, there will be further result in changes to flora and fauna composition in those riverine pools. So you've got the physical change to the river, and then you've got the ecological change that flow on from there. They're pretty vague, those predictions, but you can see that the first one is no change. The second one is two types of change. Methods, of course, are really important to prediction, and methods are usually about your technical speciality. The methods you use for noise are totally different from the methods you use for impacts on flora and fauna, and you need to have your own special expertise. This is where all of the different branches of science come to their own. But you need to choose the right sort of method, and you need to make it work. And it's not just the right method from a technical point of view, it's also from a cultural and social point of view. Indigenous people have different ways of thinking about the environment and doing things, and sometimes scientific methods are offensive to Indigenous people. So there's also a sensitivity and around the best way to do things that work in a cultural sense as well as a scientific sense. Okay, last week we started to consider the definition of environment in Western Australia, and I promised you that we would return to this topic because of this mysterious subsection 2 in the definition. So last week I gave you the top bit in green. I said the definition of environment in Western Australia. In this Act, unless the contrary intention appears, environment, subject to subsection 2, means living things, their physical, biological, social surroundings, and the interactions of all these. If you just take that bit in green, it looks like the definition of environment's everything, but it's not, because it's affected or changed by subsection 2. Just as in the European Union screening exercise, when you looked at Article 4 of the EIA directive in Europe on screening, you had to refer to the possibility of exemptions under Article 2, subsection 4. Same thing. This is how law works. Law compartmentalizes things and sends you just follow the logic. So what do we see when we look at subsection 2 for this definition of environment? Well, it gets a bit more complicated. It says, in the case of humans, the reference to social surroundings in the definition of environment in subsection 1 is a reference to aesthetic, cultural, economic, and other social surroundings. Okay, that's sounding like it's everything. It's even more than what we had before. It's additional things. It's like it's aesthetic things, cultural things, economic things, other things. But now look at the bit I've highlighted. To the extent to which they directly affect or are affected by physical or biological surroundings. Okay, you go back to part 1. We've got 3 things in part 1. We've got physical, biological, and social surroundings. And in part 2, social surroundings looks like it gets bigger and includes all sorts of things, but it's somehow tied back to physical and biological things. That's how it works. Let me explain further, because most people don't understand this initially. We had a court case where this was tested in 2018, And Chief Justice Martin said the Environmental Protection Authority is precluded from taking into account broader economic, cultural, social or political considerations which might justify a decision to allow a proposal to be implemented irrespective of its environmental consequences. So what this means is that it comes up with big mining projects all the time. This mining project's going to earn, X billions of dollars, and Australia is going to make all this money, and we're going to be rich. But at the same time, it's going to wipe out this important habitat. The EPA can't say, oh, all this money would be a good thing. They have to consider the environmental issues and in there, and not make those political kinds of decisions. But as we'll see later on, the minister is not the EPA, and the minister can consider those things when they make an approval. That's a future discussion to be had. Let's look some more at the social surroundings. So the EPA has a guidance document on social surroundings, and it addresses lots of things. It explains what impacts are, for example. That's the big box I've got there. And, it has all sorts of things like impacts on social surroundings, maybe things that disturb the ground, that has cultural associations, an Indigenous sacred site, as it were. It could be activities that impact amenity, things like noise, dust, vibration, odour, aesthetics, and it could be, aesthetics like large-scale quarries or tourism developments in a scenic area and so on. So you've got this idea that there's lots of things you might think about that are impacts on social surrounds. And then there's sections of the report on these headings that I've put there about national and historical heritage, cumulative emissions, amenity, separating industry and sensitive land uses, Aboriginal cultural heritage, and noise, dust and odour. I'm not going to go through all the details, but there's separate sections of that report that detail ideas around those things. Let's look at the one bit in this report about the economic, and this gives us a few more clues. It says here, while the Environmental Protection Act defines social surroundings to include a person's economic surroundings, this does not mean that a proposal's economic benefits, such as job creation or revenue generation, can be considered as part of EIA. And it goes on, and the bottom bit I've underlined at the base there, the EPA will consider significant economic impacts resulting from any significant impact of a proposal on the physical or biological surroundings. In other words, there must be a physical or biological change that causes an impact on economics or social surroundings. So if you look at that picture on the bottom right of the Juukan Gorge situation, the caves at Juukan Gorge, which are the oldest human habitation on the planet at the time, 40,000 years plus, it's clear that the really important Indigenous cultural site, it's clear that physically removing the vegetation and the hillside to mine the iron ore has basically completely messed up the aesthetics and amenity of that cave system that was there before. So the social impact has occurred from a physical and biological change. You understand that point? It's not about how much money the mining company made, because of course the mining company made a profit from mining the ore. It's not about justifying jobs, saying, oh, it's okay to blow up this Aboriginal site because we're going to make lots of money. EPA can't do that. They're not allowed to make those sorts of judgment calls. They have to look at the environment being more the natural environment. That's just the way it is. That's our system. Here's a recent example, Ocean Reef Marina, and this one was about the predicted loss of abalone habitat. So we have some professional and commercial abalone fishers, and abalone is a highly prized shellfish, very, very expensive. There's certain Asian cultures that think it's particularly delicious and pay lots of money for it. And it turns out that exactly where this marina is being built is the best abalone habitat on the West Australian coast. And so, of course, what that means is that the existing abalone fishers are going to suffer a loss of economic resource because their fishery is being destroyed by putting the harbour there. And that is an economic impact that the EPA can legitimately consider. So, this is what it says in the actual EPA report about it. They said, assessment of impacts. In considering social surroundings, the EPA may assess the impacts of a proposal on economic surroundings, that is, economic impacts related to the physical area involved in a proposal. This may involve consideration of the economic impacts to the Perth Metropolitan and West Australian abalone fisheries overall, and the economic impacts on licence holders who have quotas within the management area affected by the physical or biological impacts caused by the proposal. And so they did actually try to put together mitigation measures to come up with ways to try and mitigate the loss of that abalone habitat and the consequences on the abalone fishers. Some other things about impact prediction. So I know that was quite a long story about Western Australia, but you'll see it comes back and you need to kind of understand it a bit later on as well when you work through this unit. Other things about impact prediction. Well, there's a lot of different terminology you can use. I use the term prediction, but you can also use the word forecast, projection. They're all synonyms basically. And when you predict something, you can predict something that's about objects like wildlife, soil, nutrients, but you can also predict about processes, changing ecological processes and the effect that has on individuals. So that's a small point. When you make predictions, there's lots of things. When you consider the predictions you might get involved in, there's a lot to think about, which goes back to our scoping conversation. So here I've just shown some snapshots of the West Australian coastline at Mindarie Keys. Mindarie Keys is another marina development. I've used a bit of a marina theme in this last couple of modules just because we live on the coast here in Perth and maybe it interests you. Maybe you've been to some of these marinas and been to the restaurant facilities and stuff there and or had a swim at the beach or something, and you see so you can relate to them. So Mindarie Keys was another development project put up in the late 80s or early 90s. And so you can see a picture of the coast before anything happened in 1986. And you can see that the coast was straight and there was a lot of vegetation there. And then they started excavating this marina into the coastal dune system. And you can immediately see they started clearing a lot of land and exposing all the sand and so on, changing the coastal shape and the coastal form, putting in the breakwaters. And then you can see it 20 years on in 2022, urban growth has occurred around that marina, and that whole environment just looks totally different in 2022 from what it looked in 1986. So when we let's go back to 1986. We're back in 1986. We're doing the EIA. What should we be making impact predictions about? And you see, there's lots of things to think about. You know, there's probably things happening in the ocean waters there, the coastal waters. There's probably things happening with beaches and beach erosion and sand drift along the shore and things like that. There's probably a whole bunch of things happening around coastal access and access to fishing resources and what people do with the ocean. There's a whole lot of stuff about the coastal dunes and the vegetation and the animals and the plants that live in those systems and so on and so forth. But there's a time dimension there as well. You know, what is the time dimension that we're going to predict impacts around the big changes that we see over a long period of time? What is the proponent responsible for as the EIA, and what is something that's outside of that? Lots to think about. If we go now to the UK, the Environment Agency of the UK in 2002, they've got this useful guide to scoping projects and thinking about predictions. And they talked about, you need to think about, when you're predicting impacts, you need to think about three things. You need to be aware of what is the receptor, or who is the receptor of this impact? Who or what is being impacted? What is the source of the impact? we've got the development project, but what is it specifically about this development project that is causing this impact, or the source of the impact? And how does the impact arise? What's the pathway from the source to the actual cause? So, so another way of putting that is this way. You've got activities, you've got the actual things that are happening at the development activity. They lead to the causes of the impact, and then you've got the actual impacts. So my example here comes from Western Australia, from making bricks. You've probably noticed that we like building houses out of bricks here in Western Australia. And we've had brickworks in the Swan Valley in Western Australia for the last nearly 200 years. And we started making bricks literally from when colonialism started to happen here nearly 200 years ago. So in the Swan Valley, you've got good clay that's been makes good bricks. And how do you make bricks? Well, you get the clay, you put it into a square shape or a rectangular shape, and then you put it in an oven and bake it. What happens when you bake clay? Well, it turns out there are these fluoride substances inside the clay that get burnt off somehow, and they go out the chimney of the brickworks. Okay, what's the big deal with fluoride? Well, it turns out that some species of plant are particularly susceptible to fluoride, and it causes them to die. Oh yeah? What sort of plants? Well, one of the most susceptible plants are grapevines. Yeah, so what? Well, the Swan Valley happens to be a really important grape growing area for Western Australia. There's a whole tourism precinct around wineries and grapes, both table grapes and winemaking grapes. And so we've now got a conflict between making bricks and growing wine, or growing grapes, table grapes. So this is a real issue. So whenever we've had several brickworks in the last couple of decades constructed in Western Australia, and this has been one of the issues that had to be very carefully managed. You've got to make sure that brickworks are not very close to wineries and grapevines and so on. And of course, if you have death of grapevines and loss of agricultural productivity, that's an economic impact. And that you see how we've actually had a physical change under the definition of environment in Western Australia. A physical change to the environment causes the economic impact. It arises from that. And what we've done is we've traced out the pathway of that impact, or from its development activity, the actual brickworks, to the actual economic issues. Okay, so there's some things to think about with impacts and impact predictions. What else do we need to think about? Well, you can define impacts in many different ways. Obviously, impacts can actually be good, and they can be adverse. We're mostly interested in adverse, but good things are good. We do want them to happen. So adverse and beneficial. We've got the idea of a short-term versus long-term. A lot of noise emissions are short-term, you know, like if construction, the construction noise at something like the, I don't know, a marina, or building this building, or the building we're in here. A lot of construction noise when this building was underway. Now there's no noise. You know, the building doesn't make noise. Whereas something like an airport, the construction noise of an airport is probably negligible compared to the noise of aeroplanes, the massive airplanes coming and going at all times of the night, day and night. Okay, so, you know, short term, long term. Each plane is only a short-term impact, but the airport's going to be there for 100 years. So it's kind of long-term. You understand it? You start to see that, you know, you've got to explain what this impact is. If it's a noise effect from the planes, explain what that is all about, how that works. Is it reversible or irreversible? If you've cleared habitat to put in a road or a pipeline or something, and you're going to restore it afterwards, maybe it's reversible. But if it's causing species extinction, it's irreversible. If you're digging a big open cut mine, you're never going to put that landscape back, I don't think. So that's probably irreversible. So that kind of thinking. Is it local or strategic? Usually adverse impacts are often local, the noise, the dust, but the financial benefits are often regional and therefore strategic. You know, like Western Australia makes a lot of money out of mining, but the mining's somewhere else. It's not right here where most of us live. So that's always a tension point between local communities and other members of the West Australian community or Australian community. Is it quantifiable? Is it objective, or is it subjective? Things like aesthetics. You can't quantify aesthetics. How do you quantify aesthetics? Is this a nice building, the one we're in? Some people think this building looks great. Some people think it looks foul. They go, the gold building, ECU built this big gold building in the middle of the city. Ugh, what's going on? How do you judge that? That's very much a subjective kind of impact. A visual impact, aesthetic impact is very subjective. Whereas if you talk about contaminating groundwater with a heavy metal that's toxic to fish or whatever, or humans who might drink that, you're probably going to have a quantitative threshold very objectively determined around what's there or not. And then the last one is actual perceived. A lot of emotional impacts come from perceived things, and they're not real. People can suffer stress and anxiety just because they believe something's wrong. They see a big plume of smoke coming out of a chimney, and they smell something weird. Go, oh, I'm choking. Oh, I'm dying. You know, and you know that's a psychosomatic thing. In actual fact, it just might be steam coming out of there, and it's nothing to do with what's going on. So you got to tease that out as well, because psychosomatic things are real for the people who suffer them, but they're not real in terms of a physical change to the environment. And then this leads us to thinking about pathways, how impacts might move. So direct impacts, as I said, are very easy to work out. If you smash down a bunch of vegetation, it's very obvious. You've just cleared it. You've sent the bulldozer in, you've smashed it down. Then what happens? Oh, well, the trees have gone, and now the next time the wind blows or the next time it rains heavily, the soil washes away. So there's a secondary impact. Okay, where does the soil go? Well, if it's wind blown, it might go to neighbours and get all over their washing or their clothes or whatever. If it's going down the stream, it might go down to the next pool system further down a river and block the pool up. So now the pool stilts, or a dam, a hydroelectric dam stilts up because all this runoff of sediment. And then what happens? Oh, well, if the pools fill up, then the fish who live in the pools die, and you know, away you go. And what you see we're doing is we're tracing a series of one direct impact turns into a series of indirect downstream consequences. There's also the idea of induced impact. If you build a road, for example, you almost certainly end up with more development happening in that area. The most famous case study of this is the first road that was built into the Amazon rainforest in Brazil in the 1970s or thereabouts. And 40 years after that, the 52% of the land around that road had been completely deforested. If that road had never been built, you never would have had that deforestation. So should the EIA of the road have considered those induced impacts over 40 years of building that road? Certainly significant in terms of outcome. But often some people would say, well, it's not our responsibility. Our responsibility is to build the road, not to manage the forest. Well, this is the sort of thing we have to figure out. Cumulative impact and holistic impacts, we'll come back to those in later modules, but this is where we start to look at more than one thing comes together, more than one development in the case of cumulative impact, or more than one kind of impact interacting with another impact for holistic. So here's a schematic of this idea of the higher order indirect setting. This is a really old one from Shopley and Fuggle in Fugel in 1984. And this is the idea that you're dredging some mud flats. So the initial impact, the direct impact, is clearing the salt marshes and dredging of the salt marshes. So you've wiped out that plant species and its initial habitat. Then what happens? Well, the crustaceans that live there decline. Then what happens? Well, the fish that live on the crustaceans, they decline. Then what happens? Well, then the fishing industry collapses. Then what happens? Well, people stop going to the hotel and going of their summer holidays there to go fishing because there's no fish. So, you know, you trace those pathways. And in this example, the social impacts are consistent with the definition of environment in Western Australia. The social impacts, which is the decline in the hotel facilities, the economic impacts there, and the decline in recreational fishing, is the product of those ecological changes. Therefore, it's a legitimate impact that could be considered in an EIA in Western Australia. So I mentioned induced impacts, the highway example, and so that in Brazil, so there's a fast tip document from Brownlee et al. on induced impacts. So I'll leave that one with you. And then there's also this idea of scope 3 impacts or scope 3 emissions when we talk about climate change. And this is that idea of supply chains that I mentioned to you before from this paper by Lasselin et al. In Western Australia, our EPA have noted it. We've got a guideline on how to deal with greenhouse gas emissions. And the EPA note that scope 1 emissions are the things that the proponent directly emits. So if a proponent's a mining company and they're operating diesel-powered mining machinery, which is pretty common, if they're massive operation, they will have a lot of greenhouse gas emissions from burning that fossil fuels to power their mine site. They might also be purchasing energy that comes from coal-fired power stations and so on, because they need electricity as well as their mining equipment, and that's what's called scope 2 emissions. But then what happens when they export their product? So we export a lot of iron ore, for example, from Western Australia. We also, where does the iron ore go? Well, the iron ore goes off to wherever. A lot of it goes to China. And then China has a lot of smelters to smelt steel. And in the process of smelting the iron ore, they produce an enormous amount of greenhouse gas emissions. Are we responsible for those? That's a scope 3 emission, basically. To what extent should the EIA of the mine, the iron ore mine in Western Australia, consider those scope 3 emissions? That's the question. The problem being that once the miner has sold the iron ore, they have no longer have any control of what happens to it. Same with, that's the argument that's used with coal and natural gas, that the people who produce it aren't responsible for burning it, and therefore they shouldn't consider the climate change consequences. You have to figure out what you think is reasonable there, because it's contentious ground, and it's not easy to put it into an EIA either way. What we do know from this paper by Lombardi and others is that indirect impacts are hard, and they are the least well addressed aspects of EIA. It's very easy doing direct impacts. It's very comparatively hard to do indirect impacts. But our prediction process has to somehow be cognizant of all that. Okay, coming towards the end now. When we make a prediction, we also then start thinking about how we're going to mitigate that likely impact. And in doing that, we're doing an evaluation of significance. So we predict something, go, whoa, that's significant, that's nasty. What can we do about it? What can we do to mitigate it? Oh, well, we could do this. We could put some device on the chimney to extract the pollutant from the stream. We could change this aspect of our design, or whatever it might be. We could restore the land afterwards with replanting. There are all sorts of things we might do. We'll look at mitigation as a separate topic next week. But the thing is that if we've mitigated it, we've reduced its severity, and therefore our original prediction is no longer valid. You know, it's no longer accurate, and we need to remake that prediction. And that's what this diagram on the right is suggesting, that once you've made a prediction, you evaluate its significance, you put in mitigation measures to try and reduce the negative consequences, and then you need to go back to the prediction process and redo the prediction and so on, go around the loop again. So that's this idea that it's a more iterative, circular way of thinking. So mitigation is simply about avoiding, minimising, rehabilitating, offsetting impacts. We'll come back to this next week. And this diagram here, which is the diagram, my little diagram of EIA in Western Australia, shows you how this process is an iterative one. So we start in Western Australia by saying our definition of environment are the key environmental factors. So we have 14 environmental factors in Western Australia. For each factor, there's an objective. And what we ask the question is, when we do the screening process, we say, what are the relevant environmental factors for this development proposal? What would be significantly adversely impacted in one of these 14 factors? And we consider that. So we do that by understanding our environment, we understand our development proposal, and we predict our impacts. We apply our mitigation. We go, oh dear, that's significant, and we apply our mitigation hierarchy to it. We look at the environmental outcome, and if it's still significant after mitigation, we need to go back and change things. So we go back to the predictive process and go round and round. So that iterative process where we try and optimize the actual nature of our development activity and the predicted impact that's going to come out of that. And having done all that, what we're really trying to do is we're trying to ask the question, can we meet, have we met, will we meet the EPA's environmental objective? If we can meet the EPA's objective for protecting the environment, it should be okay. So we do want to try and mitigate those impacts down to an acceptable level, if you like. So this diagram here is showing you that a similar diagram in the middle of the slide there from Beamlands and Dunker. This idea that you've got similar to that Glasson and Therivel one on the left that I gave you before, showing you that the impact that we're predicting is the actual change caused by the project. And that means that in order to do impact predictions, we do have to have good baseline understanding of the environment, baseline monitoring. We need to understand what the quality of the environment is before development, and we need to predict what the quality of the environment will be after development. That's what we're doing. So to do that, we need a whole lot of technical information. And this is where we have two types of EIA practitioner. You'll have the technical specialists. You'll have the people who are trying to work out, well, what is the noise impacts of this airport? And you need sophisticated noise modeling and noise acoustics from experts who know how to measure and predict all this sort of stuff. If you're talking about, well, when we construct the runways for this airport, we're going to clear a lot of vegetation. This vegetation's in a wetland environment. Perth Airport's basically situated on a wetland system. So we're going to actually change the whole hydrology. A 2-kilometre runway of concrete, we're going to change the whole drainage patterns and hydrology of this area. How else is that runway system going to impact upon the hydrology of the wetlands and the vegetation around the airport? Well, geez, you need a botanist, botanists who specialise in wetlands, and you need a hydrologist to help you here to understand modelling of groundwater. My point being that that's highly technical, and the predictive methods that you use are going to be very specialised according to your own particular environmental expertise. I'm not one of those people. I'm one of the bottom people. I'm one of the bottom people on the slide where when we do an EIA and we have all this technical information, we've got to communicate that in one document, in one place, in a meaningful way to the public. The public are going to get to review this. And the public are not technical experts. They are not hydrologists. They are not expert ecologists. So we do need to have a way of translating and synthesizing technical content and making it meaningful to a public audience. And that's the kind of EIA that I ended up doing. I ended up being a consultant doing that kind of stuff and writing reports, and you learn a hell of a lot. You learn a lot about development and engineering, and you learn a hell of a lot about lots of bits of different environmental science, but you're still not an expert in those things. You just have to have a good enough understanding to be able to work out how to communicate that effectively to other people. So this is why I say to you, no matter what you do in your professions as an environmental scientist, you'll probably end up working in EIA. If you're a person who just loves frogs, you are the frog crazy person, you are the guru expert on Western Australian frogs, guess what? At some point, there'll be an airport proposal or a road that impacts on frog habitat, and you'll be the technical expert who's asked to do the frog predictions, the impact predictions on frogs. And otherwise, you might end up being more like I was, which was the generalist, who is the person who has those skills to communicate with the frog person, as well as other people, and distill their science into something meaningful for a document for the public. So there's a lot to think about in doing that. And when you communicate that content with people, they have questions. They need to understand what's going on. There's quite a few things that are desirable to explain to people. So, for example, first of all those things about what is the nature of the impact. Is it long-term, short-term, adverse, beneficial, all those sort of things. People want to know about that. What's the magnitude of this impact? What's the spatial extent of this impact? What's the timescale? What's the impact pathway? Is this going to happen for sure, or is it just a maybe? What's the probability this impact's going to occur? Is it a sure thing the frogs will die, or is it just, we're not, there's an uncertainty there? What's the significance of the predicted outcomes? What are the cumulative characteristics of consequences? What are the holistic characteristics? How precise is this prediction? Can we understand its meaning? Is it unequivocal what it actually is referring to? Is it quantified, for example? If it's quantified, it tends to be fairly clear. If it's a subjective, qualitative one, how well is it described? So there's a lot to think about in that regard. It also means, from a scientific point of view, you need to explain the method you use to make your impact prediction, good science. What was our method? And you need to be transparent and defensible. You need to be able to make your prediction so that someone else is convinced, and they could also look at the same data, the same evidence base, and come up with a similar prediction as yours. It's got to be transparent, and it's got to be defensible and realistic. So to round this out, let's just examine some examples. This is an assignment 3 case study option. It's a highway project. In some of I've been giving you lots of ideas about, the boxes on this slide, the adverse, beneficial, short-term, long-term, and so on, the direct, indirect, induced, the idea that you do prediction, evaluation, mitigation, the desirable content of predictions. So I'm going to share a series of screenshots from a recent EIA in Western Australia, and we'll just have a think about these things to round us out. So we're in the Tonkin Highway grade separated interchange. So this is a short section of highway, Tonkin Highway, about, where are we? About 10 kilometres from here, north and east from where we are here. And it underwent EIA a couple of years ago. We're now looking at the proponent's environmental review document. This is what the road company said would be the impacts. So what is this project? It's 4.2 kilometres of a highway. They're building flyovers, which are designed in a half diamond shape at these intersections. There's a shared path to be constructed, a concrete footpath on the side. And there's other road infrastructure like drainage, lighting, retaining walls, safety barriers, traffic signals, and so on. The total area that's affected is 51.5 hectares, and 20 hectares of that is covered by native vegetation, 1.8 hectares is landscape vegetation, and 29 hectares is already cleared. So what are the impacts? So I'm going to give you some summary prediction content from the executive summary. So what they said was, and I'm just giving you the flora and vegetation. They also had predictions on groundwater and drainage, and they had impacts predictions on fauna, and they also had predictions on social surroundings, aesthetics, noise and amenity and things like that. So I'm not going to give you the whole lot, it's too much. I'm just going to give you the flora and vegetation. So they actually talked about the potential impacts is the clearing of 20.22 hectares of habitat. And you can see they then broke that 20 hectares into the constituent parts of the different floral composition. Oh, you can see what that is. So there's remnant native flora, and there's 4.69 hectares of Banksia woodlands, and that's a threatened ecological community, so it's got particularly high value because it's threatened, and so on and so forth. And some of those species are very small areas of clearing, but the species are high priority for conservation. So that was the direct clearing. That's what the bulldozer is going to go and smash down, right? And then the box below that, I copy pasted from the next page, which were the indirect impacts, such as the introduction and spread of dieback disease, which is a plant disease that affects a lot of Australian flora. Particularly Banksia species are vulnerable to this disease. So they're not going to deliberately spread the disease, but they may, it may accidentally spread as part of the clearing operations that they have. Dust might cause smothering and suppression of vegetation. They might altering the drainage patterns might mean that further vegetation dies because the water regime's been altered. It's not the right way. So there's a few indirect impacts that they've listed in that box there. Haven't really made many predictions there, though. They've been pretty vague, haven't they? They haven't quantified any of that, have they? You notice that? None of the indirect impacts are quantified. They quantified the ones that the bulldozer is going to smash down. Really easy to work that out. You can measure them. Go, here's the number of trees, and we can measure it. It's 4.69 hectares. We're going to smash it. How many hectares of land is going to be affected by dust or by drainage or by dieback disease? Now we get into that grey, loose, woolly area. You see what's happening? You see how the communication thing starts to become really important? Then they talk about mitigation. This is what we're going to do to avoid things. This is what we're going to do to minimize things. We're going to do some rehabilitation. We're going to do some landscaping and restoration afterwards. They do all those things. And then they then have a section on residual impacts. So once we've done all those mitigation things, what will be our residual impacts? And this is what they say. It's 1.61 hectares of SCP20A, Banksia attenuata. It's 4.42 hectares of native vegetation of the Guildford complex, and so on and so forth. 3 individuals of Banksia mimica. They're really quite specific here, but they're itemising what's going on. They then talk about proposed environmental outcomes. They're saying that this loss of vegetation is a significant residual impact. Significant residual adverse impact. This is bad. So that's what they're saying. They do say, however, that they've got an offset strategy to counterbalance those residual impacts. And they have an assessment of those offsets, and they say that we believe that our offsets will end up meeting the EPA objective. You read it at the bottom. Main Roads considers that the EPA objective for flora and vegetation can be met through the implementation of an appropriate environmental offset strategy to counterbalance the significant residual impacts to flora and vegetation. So you see what's happened here. The proponent has made a series of predictions. Some are quantified, some are pretty vague. And at the end there, they've tried to say what the outcome is. They've tried to put a significance rating on it, and they said, oh, we're going to offset that. The question is, are you convinced? Is that good? How does that compare with the theory and practice, the theory of EIA from the literature about what we should do and what we shouldn't do? Okay, we're nearly out of time. I hope it's been useful to walk through that example. So I've tried to give you the theory from the literature and then show you a real life extract and get you to think, if I'm in that position, what will I do? How will I write this? What will make it a good thing? what we do know is that, as with most things in EIA, there's a lot of variation in different parts of the world and different sectors. And so these authors here, Fonseca et al., in 2020, they said, why can't we standardize? Why can't we standardize the way we do impact predictions and the way we evaluate significance? So that was the thrust of that thinking there. And that lends itself to the discussion question that underpins this module, which is about minimum standards. Should we actually have prescription standards for how we do impact prediction in EIA? If we do, what sort of standards should they be? What might they say? And how would we enforce them? And then the very final bit is about the communication. Avoid jargon. You saw that there was a lot of technical terms in those West Australian examples. Do you know what a threatened ecological community is? Do you know what a priority species is? Do you know what tech means and all that sort of stuff? So, we tend to slip into jargon. You've got to be really careful about that. We've got to do all that communication. We should be honest. We should be open. We should be clear and precise with our language. These are all the things that Glasson and Therivel are arguing for here. And essentially, it's a public relations exercise. I like this quote from Therivel and Glasson and Therivel. When we do an EIA, it's called a public relations. We are putting a public face to our, if we're working for the proponent, it's the public face of the proponent company. If you're working for the regulator, well, you're representing the people of Western Australia and the regulation of the West Australian environment. So you've got to, it's got to be good. And you don't get recognition as an individual for doing this. Like I said, EIA occurs in teams, in projects. It's the group, it's the team, it's the company, it's the organisation that is being held to account here for the work they produce. And there is this consultant from Canada, Glenn Brown, who actually he regularly comes to Australia and runs training courses on how to communicate well in EIA. And his interest is in making sure that consultants and practitioners and professionals who work in EIA are very good at communicating about the predictive effects and so on. So it's an interesting perspective. I'll skip the social versus biophysical. I'll leave that as a philosophical point to you. It's well worth thinking about. And just to close off for today, what we've done today is two or three really important topics. Screening, of course, is deciding whether we do EIA or not. Scoping is deciding what we need to focus on. And prediction is, well, how do we do that? What do we need to think about when we predict impacts on important things? And so really critical content that we've covered today. Are there any questions about prediction? Any points you want to raise about prediction? Are there any questions that you would like to raise about the assignment 1? There was a couple of people earlier who approached me and said they've got 2 of them, they haven't got a whole group. Is everybody else in a group of 3 or 4? If you're not in a group of 3 or 4, it's time to get in one. And there are at least 2 people in this room who are looking for partners to join them. I did actually suggest they get on the discussion board on Canvas and advertise a vacancy in their group. So do form a group. And then, as I said to you, I think I said this to you last week, be strategic in how you work. Go and read good literature. I keep sharing literature with you. You can see that every topic in EIA, there's lots and lots and lots of material. So go find some really good material. Send your group members out to look at different things. Come back, bring your bring back your things and share them, and then select the best ones from that. Make your work really good, because I would like that. And if you are new to ECU this semester, you've never studied here before, go and get help and get it now. I'm pretty tough. And if you failed the unit before, you'll know that I'm tough. And I'm tough because I want you to be excellent. I don't want you to be mediocre. The environment needs people who can protect it. And we're so vulnerable, so vulnerable. And if you make a stupid argument, you just get smashed down and you go nowhere. If you make a good argument, you often get ignored, sadly. That's the sad truth. It's really hard, really, really hard. You have to be very good to have success as an environmental professional. It's not easy. So it comes back to the assessment. All I expect from you is good stuff, and that's hard work. It's hard work. You saw from today when we did the screening exercise, he had to think about it quite a bit to figure out those answers to my questions about screening. You weren't rushing answers at me, right? They weren't just coming naturally to you. You had to work hard. You had to think it through. Yes, you do. There's lots of thinking, lots of work to be done. So I can't help all of you individually, but we have learning advisors like Maureen who are there to help you. If you've never done written a paper for ECU before, go find out the best thing to do. Start studying, finding out, getting some study tips in place because it'll pay off. Trust me. All right. Thank you for your attention today. We'll call it quits. I'll hang around for a few more minutes, but I will stop the slideshow. I'll just check the chat. Anything in the chat? No? All right.
Stop recording.